So now I've combined the previous two setups. So I've got both the Helmholtz coil to control the magnetic field and an additional high voltage power unit connected across the electric plate to control the electric field. So now we can, by combining the adjustments of both fields, we can use experimentally this procedure to investigate the velocity of the electrons and the specific charge of the electron. So if we first turn the electron gun on, let's get that up to a working voltage. So it's about 4,000 volts there, and we'll turn the electric field on and get that voltage up. So we're getting a reasonable amount of deflection. Okay, that's pretty much 4,000 volts on the electric field. You can see we're getting a significant curvature on the electron beam there. And now what we want to do is turn on the magnetic field and try and balance out the two sets of forces so that we end up with the electron beam emerging horizontally at the far end of the beam path. And we can do that by adjusting the current going through the Helmholtz coils. So you can see there's a slight bow in the electron beam, so it's being deflected both by the magnetic field and the electric field. I'm just trying to do a fine adjustment of the magnetic field such that the overall effect is to balance the forces, and this then makes the calculations possible to work out the velocity of the electrons and the specific charge. So there we are, that's just about balanced. And if I give you the readings and then you apply the correct formula and some of the constants from the apparatus, you should be able to work out the velocity of the electrons and, as I said, a specific charge. So the high voltages are both set at 4,000 volts at the moment, so that's the anode voltage from the electrode gun and the electric field voltage across this metal plate. The current going through the Helmholtz coil is 0.75 amps, and then the constants that you need to know are the Helmholtz coil, the number of windings is 320, and the radius of the coil is 68 millimeters. And the other constant for this equipment is the distance between the two plates where the electric field is, which is 54 millimeters in this case. So if I do some adjustments so we can get another data point, you turn the current down and turn the electric field down. Let's see if I can get another balance point. Okay, so there we've got The electric field voltage is now 2000 volts. The electron gun anode voltage is still 4000 volts. And now if I do some fine adjustment on the current going through the coils, that's pretty much balanced. That is 0.3 amps. And let's do another data point. If I take the anode voltage down to 3000 volts, let's take the electric field voltage electric field voltage is also 3000 volts now, and let's adjust the magnetic field. That's roughly in balance, and that is 0.6 amps.